Hello students, today we will do exercise 13 chapter Amines. Now 13.1 your question, write IUPAC name of the following compounds and classify them into primary, secondary and tertiary amines. Here some compounds are given to you and we have to open the structure and thereafter give the name and thereafter we will classify that primary, secondary or tertiary. Now first one you have to take CH3 twice CH NH2. It can be written like this. CH3 is given. Now CH is like this. In this CH, CH3 can be put downside of this CH and NH2 is as it is. Right? So you can write the structure like this. Here number 1 carbon, number 2 carbon, number 3 carbon. 2 contains amino. That means here propane you are given. Now NH2 is attached on second number of the carbon. That is why this is written like propane 2 amine. Propane 2 amine or prop 2 amine. This is having NH2. If any amine compounds contain NH2 group, that means it is primary amine. If only NH will be there, that is called secondary amine. And if you have only nitrogen atoms, they do not have any hydrogen, so we can say that it is tertiary amine. Here NH2 is given, that means primary amine is to be given. So here 1 degree amine is there. This is my primary amine. Okay, thereafter we are going CH3, CH2 twice NH2. That means here you can write down the structure like this. CH3, CH2 twice means CH2, CH2 and NH2 is as it is. So we can say that here amino is attached with first number of the carbon. So we can say that propane 1 amine is given. Propane 1 amine. Here primary amine that you are given. 1 degree amine you are given because NH2 is there. If NH will be there, then you should write secondary amine. Okay, now third structure, CH3 NH, CH, CH3 twice. So this structure can be written like this. Here CH. Now CH3 twice means one CH3 is and second CH3 is like this. Right? So here N contain methyl. N methyl. Now this is propane. And 2 contains amine. And methyl, this is propane and 2 numbers. 2 number carbon which contain nitrogen. That means N-methyl propane 2 amine. And methyl propane 2 amine. Right? Or here nitrogen with having 2 carbon, that means it is secondary amine. So this is my secondary amine. Okay, thereafter we are moving here CH3 thrice CNH2. That means this carbon contain 3 methyl like this. CH3, CH3, CH3. And this C contains NH2. So this is also primary amine. Right? Now carbon contained methyl, carbon contained NH2 and this is propane. 2 methyl propane 2 amine. 2 methyl propane 2 amine. 2 methyl propane two amine, and this is tertiary primary amine, because carbon, the NH2, nitrogen is having two hydrogen, that means it is primary amine. Okay, now here you can say that benzene ring is given and contains CH3, so it is your N-methyl. This is benzene amine, or you can say aniline also, N-methyl benzene amine. Right? N-methyl benzene amine. Now here you can say that CH3 CH2 and CH2 CH3, because you are having two ethyl group on nitrogen, so that is N-ethyl and methyl ethaneamine. Here you are given N-ethyl and methyl, this is ethaneamine. I will write over here N-ethyl and methyl ethaneamine. This is the name, and here you are given tertiary amine. That is your tertiary amine. This is my secondary amine. This is primary amine. Now we are moving for Bromobenzene amine. So we can say that over here, benzene ring is given to you, NH2 also given to you, and meta position contain bromo group. So here 1, 2 and 3. Here bromo, which is on meta position, that means meta bromo aniline. This is common name, but whenever you are using IUPAC name, you have to write down it in manners of numbering. So 1, 2, 3. 3 bromobenzene amine. 3 bromobenzene amine. And here primary amines are given to you. Right? So this was the question. Write IUPAC name of the following compounds and classify them into primary, secondary and tertiary. Here primary amines, because NH2 is given, NH2 is given, primary amine, NH is given, secondary amine. Now N is given, tertiary amine. Now here NH given, secondary amine. Here NH2 given, primary amine. Here NH2 given, primary amine. So we can say that whenever you are given the compound and which is having NH2, so primary amine, NH, then secondary amine, and only N will be there. So we can say that this is tertiary amine. Okay. Let us start. 13.2 exercise number. Give the chemical test to distinguish between the following pairs of compounds. Means you are given two compounds and we have to distinguish with any test. Like secondary and tertiary amine, like ethylamine and aniline. First we will take methylamine and dimethylamine. We have to distinguish these compounds. Now methylamine, that means CH3NH2. Methylamine, and dimethylamine, that means CH3NH CH3. This is my primary amine, this is my secondary amine. As you know very well that primary amine gives carbylamine test. Now carbylamine means you are having alcoholic KOH and chloroform. The mixture of chloroform CHCl3 and alcoholic KOH. This is the mixture. Now you can see that 3K and 3Cl will be removed. Right? Here this 2 hydrogen, 1 hydrogen removes with 3 hydroxide, that means 3 water molecule will be also removed. So only N and C will be remaining. That is why CH3 and triple bond C is obtained. So we can say that primary amine gives carbylamine test. But secondary amine which are not having two hydrogen, so this will not react with the mixture of chloroform and alcoholic curate. So we can say that here methylamine is primary amine, dimethylamine is secondary amine. Primary amine gives carbylamine test, but secondary amine does not give this test. Okay. Thereafter we are going secondary and tertiary amines. Now here secondary amine means you can write R2NH, and tertiary amine you can write R3N. R2NH gives the test with NaNO2 plus HCl. That means this is the mixture of NaNO2 plus HCl, which is HNO2. That means whenever secondary amine reacts with HNO2 means nitrous acid. So here HNO2 can be written like this manner, OHNO, right? OHNO. So here and this N, right? Here N does not having hydrogen, so this will not react with this. Here R2NH is there, so HNO2 reaction with HNO2 means reaction with OHNO. So what will happen? Here hydrogen removes with hydroxide, so H2O will be removed. Now N reacts with NO and forms R2N double bond NO, right? Clear? So this is R2N double bond. Thereafter R3N. Whenever R3N tertiary amine reacts with HNO2, then forms soluble salt. How it is possible? We can write HNO2. Here R3N reacts with hydrogen and forms cation. Thereafter NO2 is as it is. So this is salt. This is dye. Yellow dye you can say. So secondary amine reacts with nitrous acid and forms yellow dye. But tertiary amine reacts with HNO2 and forms salt. So you can distinguish these two chemicals by HNO2. This reaction is known as Lieberman nitrosamine test. In other words, Lieberman test. Okay. Ethylamine and aniline. You know very well that ethylamine means alkylamine. So CH3, CH2, NH2. This is my primary amine as well as aliphatic amine. Now aniline means aromatic amine and primary amine. Here you can see that ethylamine reacts with the mixture of NaNO2 plus HCl, that means forms HNO2. Ethylamine reacts with the mixture of NaNO2 plus HCl, then forms ethanol. CH3CH2OH. Right? How it is possible? Because here HNO2 contains OHNO. Right? So we can say that H2O and 2 will be going N forms N2. This is gas. Thereafter H2O will be going H2 and O. So what will remaining? H2 and O will be going. So only OH will be remaining part. That means it will attack toward here. That is why ethanol is formed. So ethylamine reacts with the mixture of sodium nitrite and hydrochloric acid, then forms ethanol. So here aniline, it should be reacts with NaNO2 and HCl and forms phenol, but it doesn't do like this. How it is possible? We can say here NH2, ring contain NH2, NaNO2 plus HCl. You know very well that this is 273 to 278 Kelvin temperature reactions and forms, you know very well that benzene diazonium chloride. Thereafter, after getting benzene diazonium chloride, it reacts with phenol, which is soluble in NaOH. So whenever benzene diazonium chloride with the mixture of phenol and NaOH, then what will form? Then orange dye will be formed. How it is possible? Hydrogen and chlorine will be removed. Thereafter these rings will be attached with nitrogen. So your compounds will be looking like this. So this is para-hydroxyazobenzene. This is orange dye. Orange dye. So we can say that when aliphatic amine like ethylamine reacts with NaNO2 plus HCl, then forms ethanol. But aniline, when reacts with NaNO2 plus 2HCl, then first form benzene diazonium chloride, and thereafter reaction with phenol, they forms orange dye. Okay. Okay, thereafter we are going aniline and benzylamine. And thereafter aniline and methylamine. Here aniline means ring contained NH2. That means you are given primary amine as well as aromatic amine. Thereafter benzylamine, that means ring contained CH2, thereafter NH2. So here NH2 is attached with direct benzene ring and here NH2 is attached with alkyl group. Okay, now both are primary amines. How can we distinguish? When any primary amine gives with NaNO2 plus HCl, that means diazotization is occurred. NaNO2 plus 2HCl at 278 to 273 to 278 Kelvin temperature. Then what will form? As you know very well that this is diazotization reaction and N2Cl is formed. N2Cl is formed. But after getting this benzene diazonium chloride, we can react with other compounds and form other organic compounds, right? But here benzylamine reacts with NaNO2 plus HCl, that means reaction with HNO2, then it forms benzyl alcohol. Benzyl alcohol. So we can say that when aniline is given, when aniline reacts with NaNO2 plus 2HCl, that means diazotization is completed, then BDC is formed. But when benzylamine reacts with NaNO2 plus HCl, that means with nitrous acid, it forms benzyl alcohol. Thereafter, aniline and N-methylamine. Here you are given ring contain NH2. This is aniline, and N-methylamine means N-methylamine. This is my primary amine, this is my secondary amine. Okay, we can say that when aniline reacts with the mixture of chloroform and alcoholic KOH, 3 moles of KOH. When aniline reacts with the mixture of chloroform and alcoholic KOH, then they forms 3K, 3Cl will remove, 3KCl will be removed. Thereafter, these 2 hydrogen, 1 hydrogen reacts with 3 OH, then 3 moles of water will be removed. Only N and C will be obtained. So we can say that by this reaction we can obtain phenyl isocyanide. Phenyl isocyanide. So reaction with chloroform and KOH, aniline forms phenyl isocyanide. Phenyl isocyanide. Thereafter, whenever the secondary amine is given, secondary and tertiary amine does not react with chloroform and 3 moles of KOH. You can say chloroform and 3 moles of alcoholic KOH, no product is obtained. So we can say that primary amine gives isocyanide, but secondary and tertiary amine does not give isocyanide with carbylamine test. Okay. Now students, we are going to solve another question. Arrange the following. Exercise 13.4. In this topic, in decreasing order of pK values, we have to find out. Means, you know very well that basic strength, if the basic strength is very high, then pKb value will be decreases. So we can say that basic strength and pKb are having inversely proportional relations. Okay. Here we can say that ethylamine given, here diethylamine given, here N-methylamine is given, and here only aniline is given. You know very well that aliphatic amines are more basic than aromatic amine. So we can say that these two are more basic, right, in comparison of these two. So here alkylamine, here dialkylamine. So dialkylamine will be more basic than primary alkylamine. Okay, so we can put over here C2H5 twice NH, which is more basic than C2H5NH2. Now you can see here amines, but N contain methyl, and methyl aniline is given. So this methyl group, which is electron donor group, that is why electron density on nitrogen will be increasing. That is why this is more basic, this is less basic. So here C6H5 NHCH3 and last C6H5 NH2. So we can say that dialkylamine is more basic than alkylamine. Alkylamine is more basic than N-methylamine. N-methylamine is more basic than aniline. So here pKb value will be very less over here. Here pKb value will be more. So we can put less than sign between them. So here pKb value will be very less, and here pKb value will be very high of aniline. In increasing order of basic strength, you can see here you are given aniline, here N dimethylamine, here diethylamine, and here methylamine. You know very well that when alkylamine and arylamine both you are given, then you have to find that you have to distinguish them as an aliphatic and aromatic. Here aromatic amine, aliphatic. You know very well that aliphatic amines are more basic than that means basic strength will be very high of aliphatic amine, and basic strength will be very low of aromatic amine. In these two amines, they are more basic, but in these two, here two alkyl group is there and here bulky group is there. That is why this is having more basic strength. Diethylamine, which is more basic than methylamine. So I will write over here C2H5 twice NH, which is more basic than methylamine. Now, in these two, here aniline, here N dimethyl here more basic because methyl group, which is electron donating group, so it gives the electron to nitrogen. That is why this is more basic than aniline. So C6H5 and right, which is more basic than aniline. So basic strength of diethylamine is very high than methylamine, which is very high than N-dimethylamine, and which is very high than aniline. Okay, in increasing order of basic strength, now which are having more basic strength? As you know very well that aniline contains ring upside NH2, para-nitroaniline like this, para-nitroaniline, right, and para-toluene. So NH3 CH3. You know very well that methyl group is having plus I effect. That means they are electron donor groups. So when methyl is attached over aniline, then they gives the electron to the benzene ring and nitrogen. That is why electron density on nitrogen will be increases. That is why it is more basic. So para-toluene is more basic, and here nitro, which is opposite nature, so we can say that nitro is electron withdrawing group, so it will accept the electron from nitrogen. So electron density on nitrogen will be very decreases. So para-toluene is more basic. In between two, aniline will be in between two. So we can write over here para-toluene, nitroaniline, which is less basic than aniline, and aniline, right, which is less basic than para-toluene. So this is the proper answer. Okay. Thereafter, in increasing order of basic strength, now you know very well that you are given all compounds contain benzene ring. Here aniline is given. Here aniline contain nitrogen and carbon. So methyl group will be donating the electron to the nitrogen. That is why basic strength will be increased. here resonance will be there. That is why these lone pair electron of nitrogen which is participating in resonating structure, that is why electron density will be less. So aniline which is having less basicity, so less basic strength contain aniline. Thereafter more will be here, and thereafter more basicity of this compound will be known. Why? Because here nitrogen does not attach with benzene directly. So methyl will be electron donating group, and that is why the electron density on nitrogen will be having more. So benzylamine which is more basic strength. I will write over here less basic strength, thereafter more basic strength, and thereafter most basic strength over here, because this is benzyl group and NH2 does not attach with benzene directly, so here plus I effect will be more in proportion. So this is the answer. Okay. Students, now we are going in decreasing order of basic strength of gas phase, in gas phase. Here you are given ethylamine, diethylamine, triethylamine and ammonia. We can say that in gaseous phase only plus I effect is responsible for basic strength in gaseous phase. But whenever we are talking about in aqueous phase, there are three major affected factors. First one is plus I effect, thereafter solvation, and thereafter steric hindrance. We have to find out in a gas phase. So we have to remember here only one thing, that plus I effect should be over there. More alkyl group will be there and more bulky group will be there, then the electron donation to the nitrogen will be more. That is why plus I effect will be high. That is why tertiary amine being most basic strength. So here tertiary amine, because here 3 alkyl group, so electron density on nitrogen will be very high. That is why protonation will be very high. So tertiary amine is more basic. Here we will write C2H5 thrice N, which is more basic than diethylamine. That means C2H5 twice NH, which is more basic than C2H5NH2, and which is more basic than ammonia. So basic strength, the order of basic strength in gaseous phase is like this. In increasing order of boiling point, as you know very well that alcohol and amines. In alcohol and amines, where H bond is very strong. Students, of course alcohol. Why? Because oxygen which are having more electronegativity, that is why here OH bond will be very polar. So most polar bond will be here, and thereafter amines. So ethanol which is having more boiling point. Ethanol which is high boiling point. Thereafter amines. But in amines, when here you are given dimethylamine, here ethylamine, so numbers of carbon will be increased. Numbers of carbon will be increased. Then boiling point also increase. So here C2H5 NH2 ethylamine, which is more having more boiling point than dimethylamine. Right? So this is the order of boiling point. Thereafter, increasing order of solubility in water. You know very well that a substance which contain less number of carbon which are having more solubility, but the numbers of carbon will be increased, then solubility will be decreases. So here methylamine, ethylamine, C2H5NH2, which is more soluble in water than diethylamine, and which is more soluble than aniline because it is having 6 carbon. So this is the order of solubility in water. In decreasing order of basic strength like this, in increasing order of boiling point like this, and increasing order of solubility in water like this. Here what we have done, if the substance contain more carbon, then solubility will be decreased. Okay, that is why this is the answer. Okay.